Thinking Like a Programmer, Part 3, Thinking in Systems. Chapter 9, Inputs and Outputs. Understanding how systems work begins with recognizing their inputs and outputs. Inputs are the resources, data, or actions that initiate a process, while outputs are the results or responses generated by the system. By examining these components, we can gain insight into the functionality and efficiency of any system, from simple machines to complex organizations. Understanding how systems work by examining inputs and outputs. Every system relies on inputs to produce outputs. In its simplest form, a system can be thought of as a transformation mechanism. Inputs go in, get processed, and outputs come out. For instance, consider a coffee machine. The inputs are coffee grounds, water, and electricity. The output is a freshly brewed cup of coffee. Understanding the relationship between inputs and outputs helps identify inefficiencies and opportunities for improvement within the system. This principle is equally applicable to non-physical systems. In customer service, for example, inputs might include a customer's complaint, the service representative's training, and the tools they use to resolve issues. The output is the customer's satisfaction or resolution of their problem. By analyzing these elements, businesses can refine their processes to improve outcomes. Examples: thermostats, websites, and customer service processes. A thermostat is a classic example of an input-output system. The input is the current room temperature measured by a sensor. The thermostat processes this information, compares it to the desired temperature, set point, and generates an output, turning the heating or cooling system on or off. This straightforward system showcases the importance of clear and accurate inputs to achieve reliable outputs. Websites function similarly. When you visit a website, your browser sends inputs, such as HTTP requests, to a server. The server processes these requests and delivers outputs in the form of web pages. The quality and speed of the outputs depends on the efficiency of the inputs and processing systems. In customer service, the process begins with a customer's inquiry, input, which is handled by representatives using scripts, training, and technology, processing. The final resolution or feedback provided to the customer constitutes the output. Analyzing these elements enables organizations to optimize both efficiency and customer satisfaction. Chapter 10, Feedback Loops. Feedback loops are essential for learning and growth within systems. They involve using the results of a process to inform and adjust future actions. Understanding how feedback works, whether positive or negative, allows systems to evolve and improve over time. Learning from results, positive and negative feedback in systems. Feedback loops can be categorized into two types, positive and negative. Positive feedback reinforces a process or behavior, amplifying its effects. For example, praise for good performance encourages continued excellence. Negative feedback, on the other hand, highlights errors or deficiencies, prompting corrective action. Both types are vital for maintaining balance and driving improvement. In a heating system, for instance, negative feedback ensures stability. If the room temperature exceeds the desired set point, the thermostat signals the system to stop heating. Conversely, in personal growth, positive feedback, such as achieving milestones, motivates individuals to persist in their efforts. Real-world examples: learning a skill, budgeting, and dieting. When learning a new skill, feedback loops are crucial. Imagine practicing a musical instrument. Positive feedback comes in the form of mastering a piece or receiving compliments, while negative feedback includes noticing mistakes or struggling with a section. Both guide adjustments, such as refining techniques or dedicating more practice to challenging areas. Budgeting also relies on feedback. Tracking expenses, input, reveals patterns that inform future decisions. Overspending in one category serves as negative feedback, prompting tighter control, while staying under budget provides positive reinforcement to maintain good habits. Dieting is another example. Weight loss or improved health metrics provide positive feedback, encouraging continued adherence to the plan. Conversely, weight gain or fatigue might signal the need for adjustments. By paying attention to feedback, individuals can fine-tune their approach for better results. Chapter 11, Error Handling and Resilience. No system is perfect. Errors and unexpected situations are inevitable. But how a system handles these challenges determines its resilience. Programmers approach errors methodically, aiming to identify, mitigate, and learn from them. These principles are equally valuable in everyday life. How programmers deal with mistakes and unexpected situations. Programmers anticipate errors by incorporating error handling mechanisms into their code. These mechanisms include validations, exceptions, and fallback options. For example, if a program expects numerical input but receives text, it might display an error message and prompt the user to correct the input instead of crashing. Error handling also involves debugging, the process of identifying and fixing the root cause of a problem. Debugging is systematic. Programmers analyze logs, test scenarios, and trace code execution to pinpoint issues. This proactive approach minimizes downtime and prevents similar errors from recurring. Learning to fail gracefully and adapt. In life, embracing error handling means acknowledging that mistakes happen and preparing to address them constructively. For instance, if a travel plan is disrupted by a flight cancellation, having a contingency plan, such as rebooking options, can turn a stressful situation into a manageable one. Resilience is about remaining flexible and resourceful in the face of setbacks. Failing gracefully also involves learning from mistakes. Reflecting on what went wrong and how it can be prevented in the future transforms failures into valuable lessons. This mindset encourages growth and fosters a sense of empowerment. Building resilient systems. Resilient systems are those that can recover quickly from disruptions and continue functioning. Whether it's a business process, a personal routine, or a technological system, resilience comes from proactive planning, robust design, and the ability to adapt. By incorporating error handling strategies and learning from feedback, any system can become more durable and effective. Thinking in systems, understanding inputs and outputs, leveraging feedback loops, and handling errors offers powerful tools for navigating complexity. By applying these principles, you can design processes that are efficient, adaptable, and resilient in the face of challenges.